2,000 years ago, the Romans built something that should not exist, a material so durable, so unnaturally resilient, that modern engineers still cannot fully explain it. Their harbors still stand in violent seawater. Their domes still hold against gravity. Their walls still breathe through earthquakes, storms, and centuries of war. Meanwhile, much of our modern concrete begins dying the moment it is born, cracking, weakening, rotting from the inside out. And that leads to a dangerous question. What if the ancient world understood something about reality that we forgot? Not chemistry, not architecture, something deeper, something about time itself. Because according to one of the most brilliant physicists alive, the answer may not only explain Roman concrete, it may explain why certain structures become stronger as they age, and why the universe itself may operate on hidden mathematical patterns we barely understand. This is where the mystery begins. Imagine standing inside the Pantheon in Pantheon. You look upward. A giant concrete dome hangs above you like a frozen planet. No steel skeleton, no modern reinforcement, just stone, ash, water, and time. 2,000 years of time. Empires collapsed beneath it, religions transformed around it, entire civilizations vanished, but the dome remained, silent, watching, waiting. And the strangest part? Scientists discovered that parts of Roman concrete are becoming stronger today than they were when the Romans first poured them. That should be impossible. Concrete is supposed to decay. Modern concrete certainly does. Bridges fracture within decades. Parking garages crumble. Seawalls dissolve under salt water. Entire cities are trapped in endless repair cycles. We build stronger machines than the Romans ever dreamed of, and yet we cannot easily replicate their concrete. But here's where it gets strange. For years, researchers assumed Roman concrete survived because it was simply better mixed. Maybe volcanic ash made it tougher. Maybe ancient builders accidentally found a lucky recipe. That explanation sounded comfortable, simple, safe. But the deeper scientists looked, the less comforting the truth became. Because Roman concrete was not behaving like ordinary material. It was behaving like a living system. Tiny cracks inside the concrete were somehow healing themselves. When seawater entered the structure, the concrete did not weaken. In some cases, it became denser, stronger, more organized, as if the ocean itself was repairing it. Think about how unnatural that sounds. Water destroys almost everything humans build. Iron rusts, wood rots. Modern concrete fractures from within. But Roman concrete seems to negotiate with water. It transforms through contact with destruction itself. And that raises a bigger question. How can damage create strength? At first, scientists thought the answer must be chemical. But chemistry alone could not explain the deeper pattern, because hidden inside the concrete, researchers found microscopic crystal structures forming over centuries, not randomly, carefully, slowly, like geometry unfolding in time. And this is where everything changes. To understand why this matters, you have to leave Rome for a moment, leave architecture, leave engineering, and enter the strange world of theoretical physics, a world where reality may not be built from objects, but from relationships, patterns, symmetries, hidden structures that survive chaos. One physicist spent decades exploring exactly that idea, a man famous for thinking about black holes, infinity, consciousness, and the geometry of the universe itself, Roger Penrose. Penrose believed something unsettling, that nature does not merely resist chaos. Under certain conditions, nature uses chaos to create deeper order, not instantly, slowly, through time. And if that sounds abstract, think about a snowflake. No architect designs it, no engineer assembles it. Yet from random motion, perfect geometry emerges. Or think about crystals deep underground. Pressure and time slowly organize matter into structures more stable than what existed before. The universe seems to favor hidden order, even inside apparent destruction. But science has found something even more disturbing. Roman concrete may be following a similar principle. Inside ancient harbors, seawater seeps through tiny fractures. At first glance, this should destroy the material. Instead, minerals begin growing inside the cracks, interlocking crystals, complex microscopic formations. The concrete evolves, not metaphorically, physically, as if time itself is part of the construction process. Modern concrete tries to resist nature. Roman concrete collaborates with it. And once you realize that, modern civilization suddenly feels fragile. Because our entire industrial philosophy is based on control. We build rigid systems. We force materials into fixed forms. We fight entropy every second. The Romans may have discovered something profoundly different. A material designed not to remain unchanged, but to adapt, to reorganize itself, to become stronger through stress. And strangely enough, Penrose's ideas about the universe point toward the same terrifying possibility. That endurance does not come from resisting change. It comes from participating in deeper mathematical patterns hidden beneath change itself. But here is the part almost nobody talks about. Penrose became obsessed with structures that repeat across scales, patterns that never perfectly repeat, yet never collapse into randomness. He called some of these non-periodic tilings, shapes that seem chaotic locally, but reveal hidden order globally. At first, this sounded like pure mathematics, abstract, disconnected from reality. Then scientists started finding Penrose-like structures inside actual physical systems. Crystals, atomic arrangements, natural formations once thought impossible. And suddenly, an uncomfortable idea appeared. What if Roman concrete accidentally stumbled into the same principle? Not consciously, not with equations, but through materials interacting over centuries in ways that create self-organizing stability. The implications become unsettling very quickly. Because if matter can slowly organize itself into stronger forms over time, then aging is not always decay. Sometimes aging is evolution. Sometimes stress creates intelligence inside structure. And sometimes destruction is only the beginning of a more stable state. But that creates an even darker question. If ancient concrete can evolve beyond its original design, what else in our world might be quietly transforming around us? Because Penrose believed the universe hides truths in places humans rarely look. Not in obvious motion, but in patterns unfolding over immense periods of time. And buried inside Roman concrete, scientists may have found evidence of exactly that. Tiny geometric signatures, microscopic arrangements that should not naturally emerge so efficiently. Structures behaving less like dead matter and more like matter learning how to survive. But part one ends where the real mystery finally begins. Because researchers eventually discovered one ingredient inside Roman concrete that changed everything they thought they understood. An ingredient so strange, so counterintuitive, that modern engineers had spent decades trying to remove it from concrete entirely. And according to Penrose's way of seeing reality, that flaw may actually be the secret behind why Roman concrete refuses to die. The ingredient was never supposed to be there. At least, that is what modern engineers believed. For decades, scientists examining Roman concrete kept finding strange white chunks scattered through the material. Tiny fragments, rough, uneven, almost careless. At first, researchers dismissed them as mistakes, bad mixing, poor craftsmanship, imperfections left behind by ancient workers who simply lacked modern precision. And honestly, that explanation made people feel comfortable, because it preserved a reassuring idea that modern civilization must be smarter, cleaner, more advanced. But the more closely scientists examined those white fragments, the more impossible that explanation became. The chunks were everywhere, not random, not accidental, intentional. And this is where the entire mystery turns upside down. Those fragments were made from lime, but not fully dissolved lime. The Romans had mixed pieces of quicklime directly into the concrete at extremely high temperatures, creating reactive pockets buried deep inside the structure. To modern engineers, this sounded reckless, dangerous, almost primitive, because modern concrete aims for uniformity, perfect consistency, no weak spots, no unpredictability. The Romans did the opposite. They embedded controlled instability directly into the material itself. And for centuries, nobody understood why. But here's where it gets strange. When cracks formed inside Roman concrete, water entered the structure. That should have been the beginning of collapse. Instead, the water reacted with those hidden lime fragments. Chemical reactions awakened. New minerals formed. The cracks slowly sealed themselves shut. The concrete healed. Not instantly, not magically, but gradually, patiently, like a wound closing over time. And suddenly those imperfections no longer looked like flaws. They looked like instructions, a hidden repair system buried inside the material from the very beginning. The Romans may have engineered concrete that anticipated damage before the damage even happened. Think about how disturbing that idea really is. Modern civilization designs for efficiency. The Romans designed for survival. We create systems that work perfectly until they fail. They created systems that expect failure and transform because of it. And this is where Roger Penrose's ideas become almost eerie, because Penrose spent much of his life exploring something most people never notice: the difference between static perfection and dynamic stability. A perfectly rigid system often shatters under stress, but systems with internal flexibility can evolve into stronger states. Nature understands this instinctively. Human engineering often does not. Look at your own body. Bones strengthen under pressure. Muscles grow through microscopic tearing. The immune system learns through exposure to threats. Even memory itself forms through repeated stress patterns in neural networks. Life survives by adapting, not by remaining untouched. And that raises a terrifying possibility. What if modern engineering has been fighting the very processes that create long-term stability? Because the Romans were not merely building structures, they may have been designing relationships with time. And this is where everything becomes philosophical. Most humans think of time as an enemy. We fear aging, decay, erosion, death. Modern materials reflect that fear. We coat surfaces, seal cracks, fight corrosion, try to freeze systems exactly as they are. But the universe does not work that way. Nothing remains frozen. Everything transforms. Penrose understood this deeply. In his view, reality itself is woven from processes that evolve through geometry, interaction, and time. Order is not something imposed permanently from above. It emerges, slowly, painfully, sometimes beautifully. Roman concrete seems to embody that same principle. Its strength was never fully present on the first day. The material needed centuries to become what it was capable of becoming. Just like crystals forming underground. Just like stars forging heavier elements through collapse. Just like intelligence emerging from billions of imperfect neural connections. The final structure was hidden inside the process all along. But scientists found something even more unsettling. The crystal formations inside Roman concrete are incredibly organized at microscopic scales. Not chaotic, not random debris, interconnected mineral networks, as if the material naturally discovers more stable configurations over time. And this echoes one of Penrose's most haunting ideas, that hidden mathematical truths shape reality whether humans recognize them or not. A snowflake does not need to understand geometry to form. A galaxy does not need awareness to spiral. Matter follows invisible laws towards certain forms of order. Roman concrete may simply allow those laws to continue operating instead of trapping the material in rigid equilibrium. Modern concrete reaches maximum strength quickly, then begins dying. Roman concrete begins incomplete, then slowly evolves. That difference changes everything, because it forces us to confront a deeply uncomfortable truth about civilization itself. We are obsessed with immediate performance, fast construction, instant results, short-term optimization. But many of nature's strongest systems emerge only through long periods of stress, adaptation, and interaction with the environment. Forests, coral reefs, immune systems, evolution, even human wisdom. The strongest things are rarely finished early. And maybe that is why Roman concrete feels almost supernatural to us. Not because it defies physics, but because it obeys physics more honestly than we do. The Romans accidentally aligned themselves with deeper natural processes instead of trying to overpower them. And perhaps that is why their structures still stand, while modern cities constantly repair themselves against collapse. But Penrose would probably push the idea even further, because beneath chemistry, beneath engineering, beneath architecture, lies an even stranger possibility: that reality rewards systems capable of integrating disorder instead of denying it. In Penrose's universe, complexity emerges from tension between order and chaos. Too much randomness destroys structure. Too much rigidity destroys adaptability. True endurance lives somewhere in between. Roman concrete may have discovered that balance long before modern science had language for it. And once you see that pattern, it begins appearing everywhere. In ecosystems, in economies, in civilizations, even in human lives. The people who survive hardship are rarely those who avoid all damage. They are often the ones who reorganize themselves through damage. The strongest minds are not untouched minds. They are minds that learned how to heal. And suddenly, Roman concrete stops feeling like an ancient material science mystery. It becomes a metaphor, a message buried in stone across 2,000 years, a warning from the past. Because modern civilization believes intelligence means domination over nature. But the pantheon still stands there in Rome like a silent contradiction, unmoving, patient, almost waiting for us to understand something obvious. That permanence may not come from resisting time. It may come from cooperating with it. And maybe that is the deepest connection to Roger Penrose after all. Not merely mathematics, not merely physics, but the unsettling realization that the universe itself seems to favor structures capable of transformation. Not perfect systems, living systems, systems that absorb stress, reorganize, and emerge more stable than before. Which leads to one final question. If ancient builders unknowingly created materials that grow stronger through centuries of pressure, what other forgotten ideas are waiting beneath history, quietly surviving, while modern civilization races toward fragility?